My name is Dr. Owen O'Shea. I'm the Research Associate for the Shark Research and Conservation Program. I also run the Stingray research here, so we're very proud to introduce these guys, and my co-advisor, Dan.
Hi, I'm Daniel Montgomery. I'm a graduate student at Newcastle University in the UK. And as Owen said, we've been co-advising this class, and we're very pleased to present the Spring 2016 Stingray research team.
Hello, good morning. Thank you all so much for coming out and joining us today. My name is Lily Kay.
I'm Talia Hoffman.
I'm Azam John Muhammad.
I'm Baker Casagrande.
I'm Emily Barges. I'm Allie White.
I'm Grayson Hecht.
And as Dan said, this is the Spring 2016 Stingray research team. Our research is looking into the thermal niche preference of the southern stingray, Daisyatus americana. And basically what that means is we're looking to see whether or not these stingrays have a temperature preference, and if so, how this temperature preference affects their choice of habitat. One of the defining characteristics of these stingrays for our research is that they're ectotherms, and this means that their body temperature is regulated by the temperature of the water around them. Previous research has shown that temperature is not only a driving factor in the segregation of male and female stingrays, but feeding and non-feeding stingrays as well. So the reason that we're studying stingrays is because they're so important to maintaining the health of their ecosystem. First of all, they're mesopredators, which means that they sit in the middle of the food chain, connecting the larger apex predators like tiger sharks to smaller invertebrates. They're also known as ecosystem engineers because they alter their habitats physically, chemically, and biologically. So when they feed, as you can see in this picture, they beat their pectoral fins, and that stirs up the sediment, and the nutrients in that little pit enter the water column, and it reoxygenates those pits for healthier microhabitats.
So, building off their role as ecosystem engineers, it's important to understand the ways in which environmental factors affect the thermal preference of these southern stingrays. However, it's also important to acknowledge that we know very little about these animals. For example, they're listed as data deficient by the IUCN. However, what we do know is that they make up a significant portion of coastal fish biomass, and for this reason, it's hypothesized that they're going to have larger impacts on these sorts of environments. And by the very nature of these habitats, that is to say, coastal ecosystems, the interface between the land and the ocean, anthropogenic disturbances such as coastal development are going to have higher detrimental impacts on these sorts of organisms.
So, a problem I'm sure everyone here is well aware of is global warming. And while global warming has a large effect on humans and our environment, it also has a very large effect on the ocean. So over the last century, ocean temperatures have been rising, and this rise is predicted to continue into the future. So this may affect the southern stingray because, as aforementioned, they are ectotherms, meaning their internal body temperature is controlled by their external environment. And so this temperature change may influence where the stingray chooses their habitat.
So the overall objective of the study is to determine to what extent temperature influences the spatial distribution of the southern stingray. More specifically, how males and females and juveniles and adults segregate their thermal niche preference in order to avoid competitive exclusion.
Now we will be discussing the materials and methods used in this study. Our research was conducted in two locations, the Schooner Keys and the Marker Bar. These research sites are located right off the shores of Cape Eleuthera. They consist of shallow sand flats that are divided by deeper water channels. We placed environmental loggers in these locations to record the ambient temperature of the water there for our research.
We chose the Marker Bar and the Schooner Keys due to the fact that they both have significant populations of southern stingrays that illustrate site fidelity, meaning they have a tendency to spend significant amounts of their time in or around these locations. This was backed up through our 55% recapture rate. Once we locate a stingray, we attempt to herd it into a large barrier net and secure it in smaller black nets. After this, we secure the barb with a wet t-shirt for the safety of ourselves and the animal. We then take morphometric measurements and install a thermo logger to the base of the ray's tail. This tracks ocean temperature every 15 minutes for up to 21 days. To retrieve this data, we have to recapture the ray and remove the thermo logger. We then compare this data to the data that was collected on our environmental loggers that have been placed in and around our research locations.
In order to analyze our data, we used a statistical test called a Kruskal-Wallis. This test compared the median temperatures of our data sets. Through this, we were able to see any significant differences in the temperatures experienced by the stingrays. We then created temperature bins to sort our data into. Bins are ranges of numerical values into which data is grouped. These groups showed us which temperatures the stingrays were spending the most amount of time. Lastly, we compared the temperatures that the stingrays experienced over a 24-hour period of time to the minimum and maximum temperatures recorded on our environmental loggers. With this, we were able to see which temperatures the stingrays experienced compared to the temperatures available to them.
So far, we have deployed 38 thermal loggers throughout our 3 capture locations. For this presentation today, we have analyzed 7 out of the 11 thermal loggers. These thermal loggers were divided into 3 distinct groups based on their median temperature preference using a statistical test. The first group consisted of 3 mature female southern stingrays and having a median temperature preference of 26.1 degrees Celsius. The second group consisted of 2 mature female southern stingrays and 1 immature female southern stingray and had a median temperature preference of 25.6 degrees Celsius. The third group consisted of only 1 mature female southern stingray and had a median temperature preference of 25.3 degrees Celsius.
So these 2 graphs show the temperature regime over a 24-hour period for 2 individual stingrays. The black line shows the temperature that the stingray experienced at each given time in the day. And the first stingray, ray 0677, was located at schooner 2, and the second ray, ray 2302, was located at the marker bar. So these 2 graphs let us compare the temperature of that the stingray experienced to the temperatures available found through our environmental loggers. So the blue line shows the minimum temperature available to that stingray in that area, and the red line shows the maximum temperature available to the stingray in that area. So these graphs let us look at the range of the temperatures that each stingray experienced. The first ray experienced a temperature range of 3.5 degrees, and the second ray experienced a temperature range of 2.5 degrees.
So, as previously mentioned, our statistical test yielded 3 groups of southern stingrays. Group 1 had 3 mature females, Group 2 had 2 mature females and an immature female, and Group 3 had a mature female, ray 2268. Ray 2268 only had 5 days of data, and for this reason, it likely didn't fit into any of the other groups because it was the lowest of all data collected. Another factor which could have affected the median temperature preference of these rays was gestation. In 2006, Wallman and Bennett concluded that female Atlantic stingrays prefer warmer waters while undergoing gestation. But we tested those waters for their pH, and we found a whole lot of P and not a lot of H. But seriously, warmer water temperatures correlate with faster growth rates and lower overall gestation time. So for this reason, stingrays are actually saving energy. We've also seen mating scars at the marker bar and the schooner keys on these rays, which shows that mating is a factor and gestation is definitely possible for a significant portion of these rays. However, in Group 2, we had an immature female southern stingray, so mating could not be a factor and gestation could not be a factor for that ray.
So these statistical tests allowed us to separate into groups, but we've also started to observe daily trends. So one thing we've noticed is that it's experiencing its lowest temperature right after low tide, and that's when all the cold water comes in. So that could be telling us that actually stingrays aren't choosing their temperature, it's just an effect of their environment. We've also seen that during the day, they're going to the warmest available temperatures, and during the night, the coolest. And that could be because during the day, they're going to the coastal flats to hide from their predators, and at night, because they're nocturnal feeders, they're going in to find their prey. As mentioned before, this is an ongoing study, so we're going to continue going out and retrieving for more information and stronger conclusions. So to wrap up this presentation, I'd like to kind of review the big picture of why we're doing this research. Basically, stingrays are important because they improve the health of their ecosystems, which not only helps the fish in the area, but the other plants and organisms as well. And when these fish and organisms are thriving, it helps the local fishermen, which in turn helps us, not only by providing us food, but by improving the economy as well. So we believe that we hope that by studying the thermal preference of these stingrays, we'll be able to better understand the areas that are most important to these species, so that we can use this information to conserve this integral species. Thank you all so much. We would like to acknowledge Katie, Rob, and Nicole, our interns. We'd also like to acknowledge Charlotte Fleming, who helped us a lot at the beginning of the semester. This is our literature cited. Are there any questions?
The question was, how do we tell the difference between immature and mature females? So what we use is their disc width. So if the disc width is from 700 to 750, under that would be an immature female, but over that would be immature female.
So it sounds to me like you hit up the book club and the college sorority, but you're missing out on the preschool and the sports club. Like, so like, is that because it's really hard to find males, or?
So what we believe is going on is that the females have a lot of site fidelity, meaning that they like to stay in the areas, and once they are somewhere, they prefer to stay in that area. And we believe that the females live here all year round, but the males only come in to mate. And so we believe that the reason that we've catch so many more females than males is that the males aren't here all year round. And while they do come, because we have seen that there are mating scars and we have caught some males, we believe that it's just the females live here all year long and the males do not.
Hi, what's the mechanism for the stingrays choosing their temperature?
I'm not sure if I have the knowledge to answer that question, but the question was, what is the mechanism for which the stingrays use to choose their temperature? And I do not think that I know that answer. But that would be super cool to do more research on and to understand.
Just about more catching the stingray itself. How long did it take when you guys finally got out to Schooner Island? You guys said, how long did it take for you guys to catch an actual stingray, and how many did you catch in a normal day?
So it takes. The question was, how long does it take to catch a stingrays, and how many we would catch throughout a normal day? So we had about a 5-hour time period to go out and catch the stingrays, and it takes about 10 minutes to get out to the schooners or as well as sandbars. And we would catch relatively 2 to 3 each outing, but I think our best record so far is catching 9 throughout the whole day if we went in the morning and the afternoon. It's relatively hard to catch the stingrays because they're incredibly fast animals. So I think it all depends on how many people specifically we have with us, because we take so many people out with us. And as Owen says, if we're on beast mode, which is big effort, a lot of enthusiasm, and running really, really fast through deep waters.
Yeah, you had mentioned that they're nocturnal feeders. This is my very anecdotal evidence. I always see them really active during the day. Do they sleep during the day? Do they tend to rest? You know, as far as over the course, I was looking at some of those graphs too, what they do.
So the question was, Lee says he's seen them be very active during the day, but do they tend to rest during the day or sleep? So from various papers we've read, we found that other ectotherms and elasmobranchs, they stay in warmer temperatures because they need less energy in the warmer temperatures during the day, and then they can go into the deeper waters to feed. So we think it's a correlation of like the energy usage being in warmer temperatures versus cooler temperatures.
gestation in warmer waters speeds up. And so, is there any study around like, are there negative impacts of that? Like, are there essentially like stingray babies being born prematurely, or is it like what are the impacts of that?
So the question was, what are the factors that can be associated with gestation, and are there any negative consequences of that? And as we said, in 2006, Wallman and Bennett did a study on female Atlantic stingrays and found that they prefer warmer waters just because when you're in warmer water, your growth rate is going to speed up, and then the gestation rate will speed up, so your overall gestation time will be lower. But what we found in that study may not be exactly applicable to southern stingrays, but the major takeaway from Wallman and Bennett was that in warmer waters, the gestation time will speed up. So definitely more research would have to be done, and I think doing that with southern stingrays, especially in this area, would probably be very interesting.